Hi to everyone and welcome to this Boyd Corporation and 3M webinar. Okay, right now I'd like to introduce today's presenters. Now joining us from the 3M Electronic Materials Solutions Division today is Joseph Petrie. Joseph is currently a 3M Electronic Assembly Solutions account manager here in the USA. He is a valuable resource for engineering and converting discussions regarding thermal interface materials, electrically conductive adhesives, shielding and grounding tapes, and EMI absorber materials for electronics applications in many markets. With over 30 years of converting experience, Joseph previously managed a 3M industrial adhesive and tape business, simultaneously holding the product marketing, application development manager, and key account manager responsibilities to drive innovative solutions with customers. Now, also with us today from Boyd Corporation is Andy Chow. Andy is an ODM sales director with over 15 years of experience working in the area of thermal management solutions. He also leads Boyd's NPI team in developing new and innovative thermal management products and applications. With experience as a global technical engineer, key account manager, and product manager, Andy is keenly in tune to the thermal management industry and attendant market trends. So, gentlemen, welcome to today's event. And with that, I'm going to pass things along to Joseph, who's with 3M, to start things off. So, Joseph, go right ahead.
Hello, everyone. And thank you for attending today's webinar discussion of 3M Thermal Interface Materials. I'm Joseph Petrie from 3M Electronic Assembly Solutions, a leading solutions provider of thermal, EMI, shielding, bonding, and protection tapes for electronics manufacturers. 3M is a company that never really stops inventing technologies and products that make companies more productive, homes more efficient, and lives better. Today, we will have a brief discussion on 3M thermal interface materials. We're going to enhanced cooling for electronic devices. Here is an artist's rendition of what the world would look like if we could see the wireless signals of the connected devices around us. And it's this explosion of connected devices driving the need for 3M electronic assembly solutions. Consumer demand is hot for more compact, more powerful electronics, but the denser circuits required for smaller devices generate more heat, making higher performing thermal management materials a necessity. In this webinar, Boyd Corporation and 3M will focus on thermal management materials that quickly and efficiently dissipate heat, even within tight spaces found in today's connected world. From oil and gas, transportation, healthcare, to connected cities, connected homes, connected cars, these connected devices are driving the need for 3M electronic assembly solutions. For example, this large rolling connected computer has many applications for 3M solutions. Throughout the vehicle, there are many materials that make new automotive innovations a reality, and thermal management is an integral part of that success. As an engineer, you have access to a wide range of adhesives, tapes, fillers, and more, including options with other desirable properties such as electrical insulation and vibration damping. Optimized for efficient processing, these materials provide unique electronic devices and make them more reliable and beat the heat. There are great resources online that explain in detail the importance of thermal conductivity. We're not going to go into a discussion of thermal dynamics today. However, it is the ability of a material to transfer heat efficiently that plays a significant role in cooling electronics. 3M thermal interface materials provide good surface wetting between two surfaces to achieve that result. There are four primary factors to consider when selecting a 3M thermal interface material. First, the thickness of the gap or area between the two surfaces we are trying to fill. For example, in the picture there's a heat sink and an integrated circuit. The thermal interface material is going to be placed between the two. Knowing what that gap could be or should be is the first thing to consider. The second consideration is the smoothness or finish of the two surfaces. The integrated circuit or the back of the heat sink, are they smooth or are they rough? The third factor is, how are the parts to be assembled? Will it be screwed together, mechanically fastened, or does your design need a high adhesion tape to hold that heat sink to that heat source? And the fourth factor is, what is the target thermal conductivity or the K value that you are looking for? We can't stress enough, it's these combination of these four basic features of our portfolio that help match the right product for your application. In the bottom center part of the slide, you can see an example of someone using too hard of a tape where they were unable to get the tape to wet out on the surfaces and therefore eliminating the air. Our goal is to replace the air with tape. And how do we do that? Well, these thermal interface materials, they're sometimes called TIMs. You might refer to them as gap pads, silicone pads. They're filled with fillers and resins that help achieve that needed thermal conductivity. However, it's a balance between the needed K value and the material's softness, or that shore or durometer to wet out on those surfaces, that delivers the application's thermal performance. One important factor when selecting a gap pad is to really consider, what is the actual gap thickness. 3M follows an ASTM standard called D5470 test method, and we only have a 5% compression. At this nominal pressure, you can expect to see the thermal conductive performance of our products. The thing to question is perhaps, why is a gap so large? You may actually find the preferred gap is not that thick or large, and perhaps you've been told to put a thicker gap pad in that application and overstuff it and then compress it with a much higher compression force than 5% to achieve the overall thermal conductivity. Frankly, it's a great way to sell more material than what is actually needed. Other engineering tips to consider is whether, do you need the product now? Do you need it immediately? 3M is a global player in the thermal interface material business with a go-to portfolio that's stocked in various countries around the world. Our acrylic chemistry is readily available worldwide and achieves some very good processing tips for Boyd Corporation to minimize scrap loss and costs. Some applications might require an ultra thick gap pad. The question would be when you're engineering that is, why are we trying to compress this thing so much? Perhaps what we need is a softer gap pad that wets out more easily at lower pressures. Remember, if you put a thicker gap pad inside your application, many times you will increase the thermal impedance. Also, if you have a thinner gap pad, you may actually be achieving a better cost saving in your design than overstuffing your application. Our converters, though, can stack our thermal interface materials to achieve gaps that might be quite large. So talk to Boyd Corporation about your application, and we will consult and design a construction that fits your particular requirements. And while we're talking, if you jot down some part numbers, consider go ahead and testing the 3M products today and have them available for your application. There are some supply chain issues in the marketplace today, and having 3M as a backup to your existing design is a way to mitigate the risk of lines down and affecting production. So this particular slide shows the expanse of our thermal solutions for your applications. We've got in the upper right corner something we call a thermal grease. It's kind of messy. It could be called a paste, but we have products in that portfolio as well. Down in the lower corner, we have a two-part epoxies that are thermally conductive, and there are some applications that require the structural bond strength of an epoxy that warrants the use of TC 2810 thermally conductive epoxy. However, for simplicity and speed, it's the 3M thermally conductive tape and thermally conductive gap pad portfolios that deliver the results for your tough engineering design challenges. So first, let's discuss a few tape options. And when I say tape, I need you to think adhesion, like a tape that will, Scotch tape that will hold and have high adhesion. You may be designing an application where the tape itself needs to hold the heat sink to the heat source. And that's what the thermally conductive tape portfolio is able to deliver. Some of our tapes, such as the 8805, if you want to jot these part numbers down, 8805, 8810, great adhesion. Starts at about 0.5 millimeter in thickness and goes up to about 1 millimeter in thickness. But there's some applications where you need a tape, high adhesion, but there's just not enough space. And that's why we even have 9882, a 2 mil thermally conductive tape solution. So plenty of tape options where you need the adhesion to help hold your assembly together. The second product portfolio here on the slide is in the lower left corner. It's our thermally conductive gap pads, interface pads. Think of gap filling. These pads typically need a secondary mechanical fastener to hold the assembly together. However, we've got an expansive portfolio that has different thicknesses as well as that shore value to wet out and achieve the best thermal conductivity for your assembly. Something also interesting to note here is how I've called out our acrylic portfolio. 3M is a large tape manufacturing company, and acrylic chemistry is in our core. And we have acrylic gap pads such as 5590H, halogen-free, or the extremely cost-effective 5571 gap pad for alternatives to what folks have been traditionally using silicone gap pads for. We also have silicone gap pads, such as our go-to products, 5591, 5583, 5516, and 19. And those are required when you need electrical isolation. Some of our products have a thin polymer on one side, as well as applications where the operating temperature approaches 130 degrees centigrade continuous. And sometimes those applications you will need are silicone gap pads. Take a look at some applications here. For example, if you're taking notes and you're working on any LED lighting applications, we're having great success worldwide using our 88 series tapes, 8805, 8810, to holding the base to a heat spreader, some sort of mechanical aluminum support or heat sink. The 8805, 8810 is an excellent choice for those high adhesion applications related to LED lighting. Sometimes, though, these LED lighting applications that require bonding or joining, relying on the adhesion, also have a requirement for UL 94 flammability. As such, 3M has a new product. It's our 8926 high adhesion thermal interface material. This construction is very good also for the LED lighting industry or other flat panel displays, chip to heat sink assemblies, printed circuit boards. But by having that ULV0 rating and being so thin, like a tape of only 0.2 millimeters, delivers and good thermal conductivity. Look at that thermal conductivity, 1.5 watts per meter Kelvin. Very good solution for a lot of designs. We talked about our thermal gap pads. Here in the electric vehicle, hybrid electric vehicle marketplace, here's an example of a battery assembly. There's a need for heat management between each one of those individual cells, the battery pack itself to maybe the case, and then this case and cells themselves to the cooling plate. These kinds of applications are filled with the 3M acrylic gap pad portfolio. And I wonder why the acrylic gap pad portfolio would be important for the electric vehicle marketplace. Here on this slide, I make reference to the fact that it's weight reduction. Weight reduction is critically important in the overall electric vehicle marketplace, and our acrylic gap pads, such as 5590H or 5571, are 20% lower weight. It has a weight reduction versus the same caliper silicone constructions. What's also interesting to note is look at the thermal conductivity of that 5590H. I put that nice red star by it because it has what is traditionally considered to be silicone gap pad performance of 3 watts per meter Kelvin, ULV0, but in an acrylic gap pad selection. Sometimes may not need that level of conductivity, so the 5571, it would be considered one of our second global go-to acrylic gap pad products. Again, these acrylic gap pads are excellent for long-term thermal stability at about 100, 110 C, but because 3M is an acrylic-based company, There's also a significant cost advantage over silicone chemistry using acrylics. Another significant advantage that Boyd Corporation can share with you is that these acrylic chemistries are available in a roll form. And what that means is, as you're designing a part, if it can be converted in a roll form, you can minimize the scrap while converting your finished part by the way it's oriented in their web. So there's some significant advantages of the acrylics regarding performance as well as convertibility for Boyd Corporation. Now, don't get me wrong, we have an expansive silicone gap pad portfolio as well. Some of them are electrically isolating. If you note there, the 5516S, 3.1 watts per meter Kelvin, has a very thin polymer laminated to one side, which really helps in that aim. So to review, our thermal tapes, thermal gap pads have both acrylic chemistry and silicone chemistry. We've got a variety of calipers and a variety of shore values that we can match to fit your design challenge. There, again, one more important point to point out with these materials is that the acrylics, they're really excellent dielectric strength. They've got good enough heat resistance, like I talked a minute ago, of 110, 130 C, and convert extremely well for Boyd Corporation to deliver efficiencies, in your design. Talk to Boyd about optimizing the part, perhaps integrating a pull tab or some sort of alignment aid that helps with your assembly accuracy and reduce variability in your final product. 3M is ready to help with your design challenges. Our electronic assembly sales team complements over 300 3M industrial and safety sales representatives. So together, 3M and the Boyd Corporation can create innovative thermal interface or bonding and gasket solutions for you. If you jotted down a few part numbers that were of interest to you, go ahead and contact 3M or your Boyd sales rep for an application discussion or arranging to have some samples sent in for testing. I wanted to finish here today by saying thank you. Thank you for letting me introduce the 3M Electronic Assembly Solutions business to you. In addition to thermally conductive adhesives for our connected world, we have a wide range of electrically conductive solutions, EMI shielding or absorbing solutions, protection tapes, bonding tapes, very, very thin tapes for electronics assembly. So in closing, I hope you gained some insight to the characteristics of key thermal interface materials, like, for example, silicone and acrylic gap pads, or even high adhesion tapes that are great for low profile applications in a wide range of industries. And there's a lot of options here at your fingertips when you're working through your design challenges, but 3M is here to help. So reach out to 3M or our converter partner, Boyd Corporation, on your next design challenge. On behalf of 3M Electronics Assembly Solutions, I wanted to say thank you for your time today and this opportunity to speak with you.
Joseph, thanks so much for that great presentation. Now, we do appreciate you taking some time to be here with all of us today. Right now, I'd like to pass things along to Andy, who's with the Boyd Corporation. So, Andy, thanks for taking some time out of your schedule today, and the floor is yours, so go right ahead.
Good day, everyone. My name is Andy Zhou, ODM Sales Director of Boyd Corporation. Today I would like to briefly introduce our thermal management and the converting solution for you.
Before we discuss thermal interface material, I would like to give you all a brief overview of Boyd Corporation. Boyd is a leading solution provider. We offer technology, material, and components. We try to solve customer complex challenge across diverse growing industry by several different solutions we have, such as thermal management, that include natural convection, forced air cooling, two-phase and passive cooling, liquid cooling system. For environmental sealing, we have O-ring, bonding and adhesive, display components, gasket, seal, and extrusion. For protection, we offer insulation, RFI, EMI shielding, noise, vibration, harshness, labeling, and identification. Boyd has been a leading solution provider for over 90 years. We are headquartered in California and have over $1 billion in annual global sales revenue and over 30 manufacturing and design centers around the world. On the right side of presentation, you will see our acquisition history, which represents the experience and the diversification of our organization.
Boyd thermal management and the converting product can serve a lot of different industries, such kind of mobile computing, consumer, enterprise, electronic, industrial, also some of automotive area. Then we have a global factory in US, in Asia, and also in Europe. We try to cover a lot of the region that we already reserve and also want to develop several new different areas. Our core manufacturer competency, we try to solve in performance challenge across thermal management, protection, and environmental sealing that needs through our precision converting. We fabricating and combine high performance raw material into custom design solution for specific OEM performance challenge. We also have a foaming process, foaming manufacture, transforming rubber, plastic, and foam compound into 3D shape customized for specific OEM application. We also have a lot of the metal fabrication that include casting, fabricating, assembly, machining, and coating metal into the thermal management solution and the assembly. Okay, let's talk about the importance of thermal management in next few slides. Why is thermal management important? As we know, there are a lot of the root cause of electronic failure, such kind of vibration, humidity, and dust. But most important root cause is the temperature. As we know, the high-tech product is getting smaller and more powerful, and also more advanced product produce more heat. So that's why after all of this root cause analysis, then we can see heat is the root cause of electronic product failure, about 55% of the time. According to Moore's law, the number of transistor integrated circuit doubles every 2 years. So simply put, electronics are getting more powerful. They also getting smaller and more compact. They create more heat. The fun fact here is today's smartphone have more processing power than Apollo 11 did when it landed on the moon long time ago. It over 1 million times more. So if we cannot avoid create a heat, then it's important how to cool down it. What does this have to do with the heat? Ever notice that your laptop starts to get hot when you use it for an extended period of time? The power that runs our electronics also generates heat. So everything that consumer power generates heat, and the amount of heat generated is proportional to the power input. In other words, the more powerful the device, the more heat. So when we're looking for multifunction, the faster smartphone and notebook, then we are really facing the heat issue. When people facing overheat issue, so they also try to develop some cooling system, a cooling model. There are two kind of system is popular in the market. Uh, the first one is a passive cooling, the cool down temperature by natural process or material without use of energy. For example, like smartphone or tablet cooling, or mainly apply in low power devices or closed environment. The material such kind of graphite sheet, the heat pipe, or vapor chamber those are materials getting popular in the future. We also see the active air cooling. They utilize international energy to cool down the temperature. For example, the server or notebook, the thermal module with a fan in the open environment. Normally, this power consumption is much higher than passive cooling. Next few slides, I would like to talk to you about thermal interface material converting and application. 3M talked about this Team 1 and Team 2 a lot in previous slides, so I don't want to go through the detail about this one. But just to let you know, when we talk about the thermal interface material related to some converting, I think the TRM2, that's a interface material between the heatsink and the heat spreader, that's also pretty important, and then also very related to converting work. This is what I want to discuss today. For the thermal interface material, there are hundreds of compound and material options you can choose. Such kind of silicone gap filler, epoxy, graphite, rubber pad, film, grease, hardware, ceramic, electrical insulating or non-insulating, high conductivity material. Some of material you can go through the converting process, such kind of silicone gap filler, the graphite, film, or the other like electrical insulating. All this one can go through the precision converting process by Boyd Corporate. In next few slides, I will let you know which process we can offer and provide a solution for you. For the precision converting process, the first one I would like to introduce a rotary die cut for you. Die cut material with ultra tight tolerance on the liner according to customer requirement. It can compensate dimension caused by unstable material. Also, this one can increase the number of material, size, layer material products, and also can combine multiple layers into one product delivery for improved assembly time and cost saving. This is a pretty high conductivity process. Next one is a flatbed die cutting. Steel rule die used for flatbed press are a cost-effective alternative to rotary dies. Automatic capability over 80 strokes per minute. It can convert the TIM material in sheet form, and this steel rule die cutting uses a stamping process to accommodate larger parts. It's up to 32 inch times 72 inch part size. The stock thickness can up to 1.25 inch thick. Next one is a plotter TIM conversion. This is a CNC type plotter that takes computer program outline to cut a complex TIM shape with a blade. The advantages include that no tooling, lower cutting cost, lower waste, and less material squeeze, and also available for thicker pad. There's one disadvantage about this one. It's only available for sheet format. So in case of you want to have some continue roll form, then you probably need to go through the rotary process. Laser cutter conversion is another low-cost solution, like a CNC type plotter that take computer program outline to cut a complex TIM shape with a laser. An advantage that include no tooling cost and cost-effective, good accuracy. The pattern change are simple, are capable to achieve more intricate and complicated design. Ideally, this is only for prototyping. The disadvantage that is a low volume. So in case of you want to do some mass production, higher volume, you should not go through this process. Water jet conversion is another low-cost solution. Also like a CNC type, a plotter that the computer program outline to cut the complex TIM shape with a water jet. The advantage also include the no tooling cost and cost-effective, and good accuracy and pattern change are simple, also capable for some complex design, and ideal for prototyping. Again, the disadvantage for this one, this process, is also for lower volume. So higher volume, you should consider the other process that I mentioned before. Next, I would like to introduce a thermal interface material integrated solution for you. We are not only provide thermal interface material, but also heat sink. Then we also can do the assembly with the heat sink and TIM to be the semi-finished parts. We also do the converting with a pull tab design in case of a customer want to have easy release the liner or pull tab. In case of some contamination concern, customer want to have a liner on the top of interface material. We also can do the converting that without pull tab design. As we mentioned before, there are 100 kind of thermal interface material. Then how to select it? Here are some guidelines and can bring you some idea of which material we should have. Such kind of what is the device size, the area, the volume, the footprint, and also are they multiple device to be cool, or this is a single piece, and what is the maximum dissipation watts of the device, and maximum operation temperature of the device, the junction or case temperature. If this is a case temperature, what's the junction to case of the thermal resistance? And what is the maximum ambient condition must operate in? So that's also important. Then also affect we should select the higher conductivity one, or we should select some softer one, and also some application that we need to focus on, like do you need some have reinforced layer or any other adhesive, the strong adhesive on it. When you talk about adhesive on it, so there's also another topic that we want to talk about. So what are the two bonding surface? Is metal to plastic, or metal to metal, or plastic to plastic? And also, does it need to be mechanical joint with adhesive, or you have a self-tacky? That's good enough. And also, what's the target thickness? Any topography challenge like pedestal or surface roughness, how much compression force you can offer, you can provide, or any electrical insulation requirement, and then what's the dielectric breakdown voltage. I think that also important when you select such kind of the interface material. When you talk about the interface material selection, there's also another topic talk about the heat spreader, and we also need to know you want to spray heat or you want to share the component and the user from the heat. and what's the size of the heat source, the hot spot, and then what's your target temperature you want to have once you apply no matter the TIM or no matter the heat spreader. Also, the available area of the heat spreader, that's also important on the selection of this heat spreader. Another important thing is available thickness of the heat spreader that you want. So basically, no matter the interface material or heat spreader, there's some guideline that you can consider when you try to select the proper one.
Thank you for attending this webinar on thermal interface material in partnership with 3M. If you have any question or would like to request a quote or sample, please contact me by email or customer service at boydcorp.com. You can also learn more by visiting our website at www.boydcorp.com and follow us on social media, LinkedIn, Facebook, and Twitter.
Joseph and Andy, we want to thank you both so much for being here with us today and for 2 great presentations. So again, thanks for taking the time to attend this webinar event. Take care and have yourselves a great rest of your day.